In this video, we will see some basic concepts about force vector. First, let us understand what are some basic concepts related to it. So, the scalar quantity is a positive or negative physical quantity that is completely specified by magnitude. So here only magnitude is required to understand the scalar quantity, like length. If it is given like as a 5 meter, then we can understand it completely. We do not need any other data. Like mass, it's a 5 kg mass is fixed, so we do not need anything. And also time, like 5 seconds, 10 seconds. So in this only one magnitude is required to understand what is the measure of these physical quantities. So that quantities are called as scalar quantities. The next is the vector quantities. So in vector, for complete description of a vector, we required its direction and magnitude. So direction is also required, in which direction and in how much magnitude it is acting. So direction is important here. And examples are the force and moment. So force is acting with some particular magnitude, but if we do not specify the direction, then we cannot understand how it is acting, where it is acting. Similarly, moment, it also requires direction with the magnitude. So those quantities which require direction and magnitude are vector quantities. And there is third quantity which is called as tensor. Tensor is for complete description of tensor. If we want to understand the tensor, then we required its direction, magnitude, and additionally we required plane on which it is acting, like stress and strain. Stress strain acts on a different planes. So direction is important, magnitude. So this will define the direction of the stress and the quantity of stress that is acting. But if we do not specify the plane, then also we cannot figure out what is the stress and strain. Means we cannot understand the nature of stress and strain. So now we will look at the addition of the two forces. So in addition of the two forces, if we consider force 1 and force 2 at some angle theta, then to find the addition, how will these two forces combinedly affect the body, then we have to simply connect both these lines parallelly, like this. We have to draw this line parallelly from the tip of the other vector, and similarly this line parallel to the tip of the other vector. And when these two lines are intersecting, at that point we have the resultant from the starting point of both the forces. So if we apply force in this direction, the combined effect will be the force which is r vector, which is the summation of both this vector. So vector representation is with the arrow, and we have to add, but in this we cannot directly add. Let's suppose this is of 1 magnitude and this is of 3 magnitude, so both the addition will not be 4. Instead of this, if we want to find the magnitude, then we have to use this formula, where f1 square plus f2 square plus 2 f1 f2 cos theta. So f1 f2 are the magnitude of these forces, and theta is the angle between these two forces. So this is how we can find the length or the magnitude of this resultant vector. And the direction is found by this drawing the parallelogram from these two parallel lines and the intersection point. So this is the direction, and this is the magnitude of this, and at what angle from any of the forces it is acting. So to find this angle, we have to use the simple trigonometry. So here if we see this is the force F1, this is the force F2, and we want to find this angle phi. So angle phi, here we have to draw a parallelogram where our resultant force is acting. Now we have to draw a perpendicular to any of the forces which we have to find, which we are interested to find the angle with. So here I have drawn this perpendicular line which is at 90 degree. So if we see this f1 is the same length f1, and we know the theta angle which is given between these two angles. So this will be f1 sin theta, and this length, this line will be f1 cos theta. If we see the total combined length will be the f2 plus f1 cos theta. So here both these vectors are parallel, that's why we can directly add. So this length is f1 plus f2 plus f1 cos theta, and this is f1 sin theta. So by this triangle we can get this phi angle, which is tan phi if we write that opposite upon adjacent. The opposite is f1 sin theta, and adjacent is this total length, which is f2 plus f1 cos theta. So this is how we can find the angle between these two resultant vector and any of the forces. Now if we see, if we want to subtract the two vectors, then we have to add the two vectors, but we have to consider one of the vector in negative direction. So here the same example, f1 and f2 is given with angle theta. So if I want to find f1 minus f2, so f1 remains as it is, but minus f2 will be in the opposite direction. So this direction we have to take in the negative direction. So here we have to go back side from this point, and we have to draw a minus f2 with the same length of magnitude. So f1 and f2 will be there. Now we have to simply take the resultant from the parallelogram method. So we have to draw parallel lines from both these two lines, and the intersection point, we have to connect the starting point of these forces to the intersection point of these forces. So that will be the resultant of these two forces, and this vector, resultant vector, will be f1 minus f2. So this is how we can calculate the resultant of the two vectors with the subtraction. So vector addition and vector subtractions of the two forces we can do like this.